Okay, so this is on rational zeros and the fundamental theorem of algebra. And it reviews what is a zero. So we know a zero is any number you plug in for x and you get 0 for y, or f of x. So algebraically I can do that if I have an equation. I can see, is -4 a 0? I don't know, let's plug it in and see. You either do it by hand and make sure that you use parentheses when you substitute, or I can do it on my calculator. I store -4 for x, plug in my equation, and it gives me 0. So I know that yes, it is a 0. I can also see if something's a 0 by looking at my table. So if I put it in here to y equals, and I go to my table, I know that it's a 0 where y is 0. So I can see here, yes, -4 is a 0 because my y value is 0. Or I could look at the graph and I could say, okay, it crosses here at -4. So yes, that is a 0. So multiple ways to see if something is a 0. Now, the degree of the polynomial tells you how many zeros you're going to have. So my degree here is 3. That means I'm going to have 3 zeros. And in this case, I have 3 real zeros because I can see them all. 1, 2, 3. Sometimes I have imaginary zeros as well. And then I may not see zeros. I may only see 1 0 here and the other 2 are imaginary. If they are imaginary zeros, they come in pairs. Remember we did this and we said, oh, if it's 2 plus I, we switch the sign and we say the other one is 2 minus I. Or if I had 4i, my other one is -4i. They always come in pairs, one with a positive imaginary part and one with a negative imaginary part. So we can look at the graph, we can look at the table, we can plug it in. We can also find them algebraically. So if I have a factored form, I can solve by setting each factor equal to 0 and solving for x. So there's a little mistake on your notes. The factored form here should be, this should be x plus 2. So if I set these equal, x minus 3 equals 0, x plus 4 equals 0, and x plus 2 equals 0, I get 3, -4, and -2. And I can easily see that those are the correct factors. There's -4, there's -2, and there's 3. Or I go to my table, and I see -4, -2, and up here is 3. All right, so now, if I use synthetic division, I can check and see if something is a factor. So remember with synthetic division, or even long division, if I divide and I get a remainder of 0, that means that that is a factor. And here's how this helps me. It helps me find my imaginary zeros. My real zeros, I have multiple ways to find real zeros, right? I can look at the graph, I can look at the table, and even if my graph does not cross at a tick mark, I know that I can do second calc number 2 and I can find zeros that way on my calculator as well. But I can't find the imaginary zeros on my calculator. So here's how synthetic division can help us with the imaginary zeros. So every time I do synthetic division, it reduces the degree of the polynomial by 1, right? I put my coefficients down, I divide, and now my answer down here is 1 less than what I started with. So if I start with x to the 4th, this is the coefficient of x to the 3rd. And I can keep going, and I can say, okay, now I'm at x to the 3rd, now I'm down to x squared. Well, when I get down to x squared, and I see that it's going to be imaginary, that's when I can actually solve it algebraically, because I know I can either use the quadratic formula, or sometimes I can just solve them algebraically pretty easily. So that's where the synthetic division is going to help us. It's going to help us get the big degrees down to quadratics so that I can find all the zeros to include the imaginary zeros. So on this problem here, I can see that it has 4 zeros because it's x to the 4th. However, when I graph it, I only see 2 on the graph, and that means I have 2 imaginary zeros because there has to be 4. So I see 2 here, I know there's got to be 2 imaginary. So right now I don't really have a way to get the imaginary answers like this. But if I got it down to x squared, I could. So I start with synthetic. I put all of my coefficients here, and I can see one of the zeros is -5, so I'm going to put -5 out there. I know that that's a 0, which means I need to get a 0 here. If I don't get a 0 remainder, I made a mistake, because I know that it is a 0, because I can see that on my graph. So I do synthetic division, I get it down to x cubed. Not small enough, I need to get it smaller. So I do it again, and I can see that I have a 0 at 3 as well, so I'm going to use that. Now I have it down to x squared plus 4. This, I could either use the quadratic formula, right? I would say a is 1, b is 0, c is 4, but this one's actually really easy to solve algebraically using the square root method. If I want to solve this, I bring the 4 over to the other side by subtracting. I take the square root of both sides, and then I know that that negative is why I have the I on the outside here, and the square root of 4 is plus or minus 2. So my 4 zeros are the ones I see on the graph, negative 5 and 3, and then my other 2 zeros are positive 2i and negative 2i. So again, everything today was pretty much a review. It's just the putting it together. So we talked about zeros and what they are. We know that zeros are roots, there are solutions, x-intercepts, it's where does it cross the x-axis. And we said we know that the amount of zeros something has is equal to the degree. However, that doesn't mean that they're all real. I could have 3 real solutions here, or I could have 1 real and 2 imaginary. But the imaginary always comes in pairs, so I never have just 1 imaginary solution. I only have 2 imaginary, or I might have 4 imaginary, or 6 imaginary. They come in pairs. So if they're all real, then I can solve it multiple ways. But if I see, like in this example on the back side, I know I'm going to have 4 solutions, but I only see 2 here. I've got to reduce it and get it down to x squared so I can solve and find what those imaginary solutions are.